This is the 2015 higher level question C2, structural forms, and this question is based around a hyperbolic paraboloid. So the graphic on the right shows a pack of potato crisps. Potato crisps have a distinctive surface shape which is based on a hyperbolic paraboloid. Projections of one of the crisps are shown in figure C2 below. The perimeter is an ellipse in plan. The surface of the crisp is formed by extending the hyperbolic paraboloid surface ABCD. For this question, part A, draw the given plan using the same number of elements in each direction on the surface of the crisp as shown. Part B, project the given elevation from plan. Part C, show the curvature of the surface when intersected by a vertical cutting plane passing through points BD. And finally, draw the plan and elevation of the shortest distance between the two skew lines AB and CD. So this is a scale of 2:1, so everything's getting enlarged. So everything is going to be twice as big as the measurements say. So I've started to set up this question. I kept this line up about 100 millimeters from the bottom just to give myself enough space underneath, as we don't know exactly where it's going to fit. The distance from A to C is given as 75, so doubling that it's 150, and then points B and D are found by taking lines at 35 degrees from this major axis, and where they intersect will give us those 2 points. Locating points in the elevation is found just by projecting them from the plan. So A and C are going to be on the XY line. B and D are up at a height of 50, doubling the 25 that's given. So this is point A, this is B and D, and this is point C. So we are given an ellipse. We're told that the curve ABCD is an ellipse in plan, and I'm going to use the Trammell method to find it. You can use the concentric circles method if you wish, but it will block up everything quite significantly and put a lot of construction in the center of this, which you could probably do without. So I've measured first half the major axis from 1 to the center, so that's point 1 and point 3. Point 1 I'm putting now onto the end of the minor axis, which is point D, and again finding the crossing point, and that's calling that point 2. So how this is going to work, 2 is going to move over and back across the major axis, 3 moves up and down across the minor, and it's going to plot my curve. So just as this moves around, plotting points as we go. So as I said, concentric circles method is an option, but that will involve having a lot of lines in the middle. And if we're trying to put our element lines in there, or Genustrix lines in there in a while, that's going to block it up quite significantly and maybe make it a little bit more complicated than it would need to. So I'm just going to pause this video here now and draw the rest of them in. So that's just after completing the ellipse down in plan. I have my lines A, B, C and D. I'm just going to find those in the elevation now as well. A, B, C and D. And I'm going to use, then I'm going to look at finding the Genustrixes, the lines here in each of the views. So I need to divide these up into a number of equal parts. As they're all the same length, if I divide one up and copy that distances, it'll work the same. So if I just take line off one of them at any angle, and I'm going to mark off 5 equal sections. So I'm going to pick 20 millimeters just because. Join the final point to the end of the line. And then I go parallel to that back to the line that I'm dividing up. So that divides that line up into a number of equal parts. If I was to take then lines parallel, I'll find the ones on the opposite side. So I can draw in my lines going parallel to the opposite side. So you can copy the distance again if you like, or I'm just going to redo this as it'll be quicker than trying to copy the distance. So again, going parallel to the lines AD and BC, I can draw in my Genustrix lines. I'm going to put them all the same color because in the elevation they're going to be on top of each other anyway. Now, before we go finding any part of the curve up here in the elevation, I'm just going to find these points up here first, and then I'll explain how we're going to find what the curve is supposed to look like up here in the elevation. So each point is projected straight up. I'm just going to zoom. So just going to locate each point now up in the elevation. Now this ends up being two of them because they're in line with each other, so that ends up being this line going this way and this line going the opposite way, which is why they wanted you to use the same number of lines going in both directions. So we can just continue projecting finding these same lines, Genustrix lines up in the elevation. So that finds all of those lines now up in the elevation. What we need to do next is we need to find what this curve looks like up here. So the curve underneath is straightforward. That is just going to be found by joining this point to halfway along here, and so on. So halfway along each of those, and I'll join that in now. That gives me the curve underneath. So that's the curve at the bottom. So that's just found by joining those lines up. The curve at the top is different. It's not formed by what these lines appear as. It's going to be based on this curve out here. So what we need to do is we need to extend the Genustrix lines on in plan. And I haven't done that purposely before now. So extend those lines on in plan. Extend that same line on up in the elevation. And where they intersect each other up in the elevation is going to be a point on the curve. So it's going to come as far as here, that being a point on the curve. So I'll do that again for the next one. So I extend on my generator line, the blue line, extend that on until it touches the curve. Find that point in the elevation. So extending until it touches the curve, projecting that up into the elevation, and then extending that generator line on until it touches off that point, giving me my points on the curve. So extending each of these on. And this one's extended on as well to intersect. and this final one will be also. So that gives me a number of points up here. So I can just extend those lines on. And then all it is a matter of joining these points up. And that's going to give me the curve in the elevation. So I'll do the same thing on the opposite side, so extending the lines on. And where they're extended on, they intersect. So each time this happens, and joining all of these up, applying points to form the curve. And that completes the elevation. So just a quick recap what we've done here. I've extended the generator lines beyond the line AB until they intersect the curve. I then project this line up into the elevation, and as I extended the line in plan, I need to extend the line in the elevation also, and where they intersect is going to give me the point on the curve that I'm looking for. So if it was this line here, this one is extended down until it touches off the ellipse, project it up into the elevation, extend the line again in elevation, where they intersect is the point on the curve that I'm looking for. So that completes the first two parts of this. Draw the given plan using the same number of elements in each direction, and project the given elevation from the plan. Next part of this is going to be to draw, show the curvature of the surface when intersected by vertical cutting plane passing through points B and D. So we need to find what the curvature of this surface looks like along this line here. So, and cutting through that there also. So we can do that in two ways. We can project an end view out here, or an auxiliary view out here, or we can draw an end view. Either way will work the same, and we'll be taking heights from our elevation either way. So what I'm going to do is I'm going to project an auxiliary view out here to the side. As I said, the other one works much the same as well. So point B is projected out, and D, and I'm going to put in an X1, Y1 line. So lines are projected this way. And what I need to do next is I need to locate the height of B and D. So those heights are found from the elevation, and they're both up 50. This is a D, and this is B. So that height was given to us in the question when we started. What I need to do next is every time along this red line, which is going to be my vertical cutting plane, everywhere along that red line that one of my Genustrix lines intersects it, is going to be able to give me a height. So if I find the same line in the elevation, so this line would be this line, that can give me the height that this point is, where these two lines cross, is at this point in the elevation. So I can take that height and mark that out over here. So this one and also this one are going to be at the same height. So I can measure the height with my compass or with my set square, measure what height that is. So if you need to know which one it is, extend the line on until it touches the line AD, find that on up here in AD and bring it back. That's this line here. So I'm measuring this height, which is 34 millimeters. So I can mark 34 millimeters here, and on the other one, because they're both at the same height. Do the same thing for the next line down. So that's going to be at this point. So following that one up, that's going to be this one. So I can project out both of these. And again, measure the height. And this is just over 25. Those 2 points, and now I need to find the bottom point, also the lowest point So that one should be projected out also, and that's found because you've already drawn your curve in down here at the bottom, whatever height the lower point is down there, and that's 24. So once we have all of these points, again, best freehand curve that you can. Joining all of these up. And that gives us the curvature, which you couldn't see, along that. So just a quick recap again so that you can actually see what I'm talking about. Taking this point here, that's two intersecting lines, finding that one, that's this one, on the line AD, this point on the line AD, so that follows back and that gives me this height. So I can take the height that this is here and mark that up in my auxiliary view. So whatever height I've taken here, that's the corresponding height for it here. For the next one down, where the two blue lines cross, and here, that's going to be these two crossings here. So I can copy that height here and here also. So it's just a normal auxiliary measuring my heights from the elevation. Again, as I said, you could have drawn this as an end view if you wished. So we'll just look at the question again, and the final part of this is draw the plan and elevation of the shortest distance between the two skew lines AB and CD. So the shortest distance is going to be the shortest perpendicular distance between them. So I need to look in perpendicular to both of these. As they're already parallel to each other, I don't need to draw a first auxiliary first to then find where they're going to cross each other. I have this, that view, my first view will be showing them already parallel because they are already parallel here. So what I'm going to do is I'm going to draw an x2, y2 line up here, or a second x1, y1 line up here, and project points A, B, C, and D up into that auxiliary view. So going parallel to the line CD, so it's inclined at 35 degrees as we set up in the question. So projecting all these points up here, so this is going to be my x1, y1, projecting C and D up into those views, and projecting the other A and B up here also. So just extending the lines. Now, as this is an auxiliary elevation because it's projected from a plan, which you cannot see. So, just talking about that again, really need to show you what I'm doing. I've taken an auxiliary view, it's an x1, y1 line up here that is perpendicular to the line AB and CD. So AB and CD, they're the two lines as they're already parallel to each other. As they're already parallel here, I don't need to find the view where they're going to be parallel. This is the view where they're parallel. So I can now look in perpendicular to both of them. So I'm projecting an x1, y1 line up here, an auxiliary elevation. I can, once I've projected all of these up here, I'm going to take the heights from my normal elevation, my first elevation, because my rule for working with auxiliaries, if I'm working in this one, I'm skipping this view, measuring from this view. So A is on the ground, point C is also on the ground, and need to locate B and D. So B and D are both up at a height of 50. So that's B, and D is located here. So D joins to C and A to B. Where these cross each other at this point here is the point where they are closest to each other. So they're going to give me the shortest perpendicular distance between them. So what I can do now is I'm going to project this back down into this view and find where they that is on the lines AB and CD. So just projecting that point back down in again. This line is projected back down, and that crosses the line DC here and BC or AB here. So the shortest perpendicular line that I'm looking for is this one here. This is the shortest perpendicular line located between both of them. So this here is the shortest distance between the lines CD and AB. I need to locate them now in the elevation, and to do that they're just projected straight up into the elevation. You could also you can also measure the height from the auxiliary view if you wished. So CD that's a point on that there. That's that there. And as they're both at the same height up here, it should be a horizontal line in your elevation. So this here is the shortest line between the two. So that's this line here. So joining these 2 points. So this is it in plan, this is it in the elevation, and this is a point view of that line in the auxiliary view. So that concludes the 2015 higher level C2.